P0307 means the PCM is seeing a misfire contribution problem on cylinder 7. On this Ram 1500 with the 5.7 Hemi, the driver may feel a rough idle, a shake under load, reduced power, or a flashing MIL if the misfire gets severe. The possible fault areas can include ignition, fuel delivery, air leaks, fuel quality, engine mechanical issues, valvetrain operation, oiling concerns, wiring, or PCM side control. Start by confirming the condition is active. Turn the ignition on, read and record the codes and captured operating data, then operate the vehicle under the same captured conditions. During the road test, note exactly when the misfire shows up, watch the downstream O2 sensor activity while it is happening, and use the misfire monitor to confirm cylinder 7 is the cylinder counting excessive misfires. If cylinder 7 is not misfiring now, treat it as an intermittent condition instead of forcing the rest of the pinpoint test. The misfire monitor only tells the truth when its enable conditions are met, so make sure the monitor gates are reasonable before judging the result. The monitor runs with fuel level above 12%, battery voltage above 9 volts, ambient temperature above -23 degrees C, -4 degrees F, coolant temperature at engine start above -7 degrees C, 4 degrees F, or after engine temperature reaches 21 degrees C, 8 degrees F, if the start temperature was below the threshold. Engine speed also has to be between approximately 400 RPM and 6,200 RPM, and the monitor is disabled during a decel fuel shutoff event. The code sets when crankshaft speed variation between cylinders exceeds a calibrated value for the current engine speed and load. If other active or pending codes are present in the fuel system, ignition system, air handling system, VVT system, or VVL system, diagnose those first because they can drive the cylinder 7 misfire result. Next, do the mechanical and underhood inspection. Look for accessory drive problems like a worn serpentine belt or a pulley that is misaligned, binding, or loading the engine. Check that the crank, cam, and MAP sensors are mounted correctly, and inspect connector and terminal condition at the major inputs and outputs, including sensors, throttle body, injector, ignition coil, and PCM power and ground circuits. Also look for vacuum leaks, induction or exhaust restriction, signs of internal engine trouble, moisture on ignition parts, insufficient or poor quality fuel, and operating conditions like bogging or towing overload. If you find a fault here, repair it and verify the repair before moving on. With the ignition off, inspect the MDS solenoid harness connectors, jumper connectors, and terminals. Look for poor connector installation, damaged locks, corrosion, water intrusion, damaged seals, bent terminals, overheated terminals, terminals pushed back in the cavity, spread terminals, and weak terminal tension. If anything is wrong, repair it and verify the repair. If the connectors check out, check the engine and intake manifold for vacuum leaks. Repair any intake leak found. If no leak is found, check the fuel for water, correct fuel type, old or contaminated fuel, and low fuel. Also check for proper ethanol level in the gasoline. If the fuel is the problem, replace the fuel and, if needed, flush and clean the fuel system, then verify the repair. Now move to the injector check. The fuel system can hold pressure even with the engine off, so release fuel pressure before opening any hose, fitting, or line. Install fuel pressure decay tester 8978A at the fuel rail. Turn the ignition on. Let pressure reach maximum and stabilize, and record that as the starting pressure. Actuate the fuel injector for cylinder 7 with the scan tool while watching the gauge. Then record the ending pressure. Repeat the same test on several known good cylinders, always starting at the same pressure, and compare the ending pressures. After each injector actuation, start the engine to clear fuel from the cylinder to avoid engine damage. If cylinder 7 ends up about the same as the good cylinders, keep going. If the drop is too small, check for debris in the fuel rail or injector and repair as needed. If the drop is too large, suspect a faulty or fouled injector, then verify the repair. Before continuing, remove the fuel pressure tester and reconnect the fuel lines. With the ignition off, remove the ignition coil from cylinder 7, reconnect the coil connector, disconnect the cylinder 7 injector connector, and install a spark tester on the coil. Crank the engine and look for a crisp blue spark. If spark is good, inspect the spark plug and cylinder. Remove the plug and look for cracks, carbon tracking, oil fouling, coolant fouling, excess fuel, an out-of-spec gap, or a loose or broken electrode. Also check for signs of oil or coolant in the cylinder. If any of those plug conditions are present, replace the spark plug. If oil or coolant is in the cylinder, diagnose and repair that cause, then verify the repair. If the plug and cylinder inspection do not explain it, perform a compression test on all cylinders and compare cylinder 7 to known good cylinders. If compression is not within specification, use a cylinder leak-down test to determine whether the cause is in the valvetrain or combustion chamber, repair as needed, and verify the repair. If compression is within specification, swap the cylinder 7 spark plug with a known good cylinder, or replace the plug if access makes swapping impractical. Start the engine and watch the misfire monitor. If the misfire moves with the plug, replace that plug. If the plug was replaced and the misfire is gone, that repair is complete after verification. If the misfire does not move or go away, continue. If the misfire stays on cylinder 7, decarbon the engine using MOPR combustion cleaner. After driving and clearing the cleaner from the engine, erase the codes, repeat the captured operating conditions, and watch the misfire monitor. If the misfire does not return, the valve and combustion chamber cleaning repaired the fault. If it returns, check engine oil level and condition before going deeper. Look for mechanical tolerances out of specification, oil pressure out of specification, low oil level, an incorrect oil filter, deteriorated or dirty oil, contaminated oil, incorrect viscosity, or aerated oil. Repair any oiling or mechanical condition found and verify the repair. If none of those are present, consider VVL only if the misfire happened when engine speed exceeded 5,000 RPM and the VVL system is suspected. A rocker arm stuck in low lift can cause a misfire at or above approximately 5,000 RPM and may not set a VVL system code. Before checking rocker arms, make sure the VVL solenoid O-rings are not missing or damaged, and that the solenoid is not leaking when off. Then inspect the camshaft, rocker arms, and springs for excessive wear or broken parts. Repair confirmed VVL or valvetrain faults as appropriate, then verify the repair. If cylinder 7 did not have a crisp blue spark, move to the coil circuit checks. Keep clear of the fan belts and pulleys with the engine operating and do not wear loose clothing. With the ignition off, disconnect the ignition coil connector. Turn the ignition on, actuate the ASD relay with the scan tool, and use a 12-volt test light connected to ground to probe the ASD relay, F342, output circuit at the coil connector. If the light does not illuminate brightly, stop scan tool actuations. Repair the open or short to ground between the PDC and the ignition coil connector, and verify the repair. If the feed is good, connect a 12-volt test light to a 12-volt source, back probe the coil control circuit at the ignition coil connector, and crank the engine for 5 seconds. If the light blinks brightly, replace the ignition coil and verify the repair. If the light stays on constantly, check the coil control circuit for a short to ground. If the light stays off constantly, check the coil control circuit for an open. For the short to ground check, turn the ignition off, disconnect PCMC2, and use the GPEC Diagnostic adapter 10436 on the engine harness side. Do not probe PCM harness connectors directly, because that can damage the terminals and create poor pin contact. Check continuity between ground and the coil control circuit at the ignition coil connector. If continuity to ground is present, repair the coil control circuit short to ground and verify the repair. If there is no continuity, continue to the final connection checks. For the open circuit path, measure resistance in the coil control circuit between the ignition coil connector and the GPEC adapter. If resistance is not below 3.0 ohms, repair the open or high resistance in the coil control circuit and verify the repair. If resistance is below 3.0 ohms, continue to the final connection checks. At the end of the path, disconnect the PCM connectors, related inline connectors if equipped, and related component connectors. Inspect every male and female terminal for connector fit, lock damage, corrosion, water intrusion, seal damage, bent terminals, overheating from poor connection, terminals pushed back in the cavity, spread terminals, and terminal tension. Repair any condition found, reconnect everything fully seated with the locks engaged, erase the codes, and operate the vehicle under the monitored conditions. If P0307 does not return, the wiring or poor connection problem has been repaired. If P0307 does return after those checks, the supported next step is to replace and program the PCM, then verify the repair and confirm the code stays gone. The takeaway is simple. Prove the cylinder 7 misfire first. Eliminate shared causes. Compare fuel and spark to known good cylinders. Then only go into circuit and PCM decisions after the mechanical and connector checks are clean. For more diagnostic training, visit stepdiagnostics.com.